The decimal point. It can cause a lot of problems for students when they first learn about decimals and their fraction equivalents. But the decimal point is like a lot of symbols in mathematics. It's a convention. Its sole purpose is to identify the unit. And that unit can be anything. For example, in our monetary system, the decimal is used to identify the dollar as the unit. The example shown here is $927.36. The decimal denotes the dollar as the unit. There are 9 hundredths, 2 tenths, 7 ones or units, 3 tenths or dimes, and 6 hundredths of a dollar, pennies. If pennies were the unit, the same amount of money would be written 92,736 cents, or 92,736 and 0 tenths cents. It could also be written as 92 and 736 thousandths tens of dollars, or 9,273 and 6 tenths dimes. In another example, sometimes we hear on the news about a city's population increasing to 6 and 1/10 million people. Here, the unit is millions of people, and it's the same as 6,100,000 people. So the questions I know are still out there, even though we know what the decimal is and what it does, right? What's wrong with moving it to perform computations? Isn't the goal to get the correct answer? Something must be moving. If it's not the decimal, then what? I'd like to answer these questions in no particular order. First, teaching tricks is never the right way to go because it's never what's best for kids and it never makes sense mathematically or developmentally. Teaching tricks, like moving the decimal, lead students to unlearn any conceptual understandings they may have built. The main goal in mathematics is never answer getting. It's sense making and reasoning. So let's go back and take a look at how students learn about place value. When teaching first grade students how our base 10 system works, students often collect things like popsicle sticks, as you see here. They usually collect one per day, and as they collect more and more, they count and write the number of sticks in a place value chart. And once they get to 10, they bundle them together to make a group of 10. And once they make a group of 10, where they write the digit moves one place to the left. No decimal moved. It was the digit, in this case where we wrote that digit, that shifted. They continue to count their popsicle sticks and make groups of 10, writing the numbers in the place value chart, showing the groups of 10, and any ones or units that are left over. So starting with one popsicle stick and adding a popsicle stick each day, after 10 days there are 10 times as many popsicle sticks as when we started. And to get from 1 to 10, I don't move a decimal. I shift the digit from the ones or units place to the tens place. It's the digits that shift based on their value changing due to what's happening. Students continue to build on this understanding as they work with hundreds in second grade and thousands in larger numbers in third and fourth grades. Decimal fractions and decimal notation are introduced in fourth grade. They connect the ideas of fractions to decimal fractions, and then to decimal notation to the hundredths place, and compare these quantities using visual models. These ideas are extended in fifth and sixth grade to include operations with decimals. Operations with decimals can become problematic, specifically with multiplication and division. The students are taught tricks like moving the decimal when they multiply or divide. This is misleading, does not build on any previous mathematical understandings, and often promotes students blindly following procedures without reasoning about the quantities involved, rather than sense making. This leads to many of the problems with decimal multiplication and division, where students get unreasonable solutions to problems and they assume that they're correct because students are hyper-focused on following the steps and don't think about the values of the numbers and what's happening to them as they're being operated on. In decimal multiplication and division, the digits shift because as we multiply and divide, the values of the digits change. The reason we teach multiplying and dividing by a power of 10 before any other multiplication or division is so students can discover the patterns of what happens to the values of the digits. When we multiply by 10, each digit gets 10 times greater. So the digits need to shift to the left. If the value of the digit becomes smaller by dividing by a power of 10 or multiplying by a fraction such as 1/10, then the digits would shift to the right. Let's take a look at $927.36 again. If I multiply this number by 10, each of these digits gets 10 times greater, so they have to shift to the left one space. The 900s becomes 10 times greater to make 9,000s. The 2 10s becomes 10 times greater to make 200s. The 7 1s become 10 times greater to make 7 10s. Likewise, 3 10ths become 3 1s, and 600ths become 6 10ths. And it looks like this. So now that you know that it's the digits of the number that shift because of their values changing, how do you teach multiplying decimals and dividing decimals without moving the decimal point? Well, we still have to place the decimal somewhere to show where that unit is. And to determine that unit, we can use estimation and reasoning. If I'm given a context where I need to multiply two decimals, first I can estimate what the answer will be close to. In this example, I need to buy some carpeting for a room in my house that's 2 4/10 meters wide by 6 8/10 meters long. So I need to find the area of my room. Well, if I consider the values of these numbers, I could reason that the area will be a little bit more than 2 times 7 or 14 square meters. Or I could get a little more specific, I guess, and I could reason that it's a little less than 2.5 times 7, which would be a little less than 17.5 square meters. And that's all I need to know to place the decimals, so it identifies the correct unit, which would be square meter. All I need to do now is multiply these numbers as if there were no decimals. And this is something I've been doing for a couple of years. So here's how I like to do this kind of multiplication with an area model, where I'm multiplying 60 and 8 times 20 and 4, and I can multiply to get each of those partial products, and then I can add across horizontally and get 1,360 and 272, and I can find out that the digits in my solution are 1, 6, 3, and 2. Now I know my answer can't be 1,632 square meters because of the estimations that I did. But since I know the digits are 1, 6, 3, and 2, and I know that my estimate told me that my answer is a little greater than 14, I know that the unit, or square meter, or the ones place, must be where the 6 is. So I know I can correctly place my decimal between the 6 and the 3. So I know my answer is 16 and 32/100 square meters. Mathematics makes sense. Ideas are connected, and not allowing students to make these connections creates gaps in understanding, which in turn creates frustrating situations based on memorization that compound over time and from which too many students never recover. Mathematics isn't magic. Stop teaching tricks and help students make mathematical connections.